Hello everybody, it's Mr. Math. Today's topic is basic limits. Let's get to work and do a few problems. Our first one is the limit of x approaches 4 at 3x. So what we're going to do is use the basic limit property, plug in our 4 to our x in our equation. So we'll plug in 4 for the x. 3 times 4 is what we now have. This equals 12. Fairly easy one. Let's try another. So we have the limit as x approaches 3 of 5x plus 2. It's very important to include parentheses here. So again, we'll use the basic property and plug in 3 for our x. So we'll get 5 times 3 plus 2. Now we're left with numbers, so it's just arithmetic. So this equals 15 plus 2. And this equals 17. And that is our answer. Let's try some more. So we have the limit as x approaches 6 of x squared. Once again, we'll use the basic property, plug in our 6 for our x. And this yields 6 squared. And as we all know, 6 squared is 36. And that's our answer. Let's try another. We'll have the limit as x approaches 5 of 3. Now this one's interesting. You may just say 5, but no. Since there's nowhere to plug in 5, we don't even do anything. Our answer is just the coefficient, which is 3. They're going to start getting a little harder. What we have now is the limit as x approaches 2 of x squared plus x minus 6 all over x squared minus x minus 2. So you might say now, oh, why don't we just plug in 2 like in the last few problems? Well, let's give that a shot. If we do that, we're left with 2 squared plus 2 minus 6 all over 2 squared minus 2 minus 2. This gives us 4 plus 2 minus 6 over 4 minus 2 minus 2. And this gives us 4 plus 2 is 6 minus 6 over 4 minus 2 minus 2 is 4 minus 4. And this gives us 0 over 0, the evil of all math. So we're left with something that doesn't exist, which we can't have. So let's try another way. So instead of just plugging in our 2 right away, let's factor. Factor the top and the bottom. The factor of x squared plus x minus 6 is simply x minus x plus 3, x minus 2. And the factor of the bottom is simply x minus 2, x plus 1. Well, look at this. The x minus 2's will cancel. And we're left with this. X plus 3, x minus 1. Now let's not drop our limit. I dropped my limit. Let's not do that. Limit as x approaches 2 of this. Now we can plug in our x approaches 2 for our problem. So we're left with this. 2 plus 3 over 2 minus 1. This yields 5. I'm sorry, this is a plus. My bad. Plug in our 2 plus 1, 3. And our answer is 5 over 3. We now have the limit as x approaches 0 of sine 2x over x. Now, once you get to more other videos, you'll learn different methods to do this problem. But for now, we can only use the definition sine x over x as the limit approaches x approaches 0 equals 1. In this case, the coefficient is 1, but in this case, the coefficient is 2, so our answer is simply 2. Here we have a problem like the earlier one. Limit x approaches 4 of 1,000 over infinity. Well, we know that anything over infinity is 0. So let's rewrite this problem as the limit of x approaches 4 of 0. As we learned in a previous example, if you cannot plug in the x for the limit, the answer is simply the coefficient, which is 0. So your answer is 0. It's getting fun. Limit as t approaches 4 of 3t minus 14 all over t plus 1. Now you might be saying to yourself, oh my gosh, there's no x, what do I do? Well, that's completely okay. You can treat the t just like the x or any variable they put here. So we'll use the definition, plug in t equals 4. So this equals 3 times 4 minus 14 over 4 plus 1. This simplifies to 12 minus 14 over 5, and this simplifies to negative 2/5. Hence, this is your answer. Just a few more left. We now have the limit as t approaches 2, remember, don't forget about the t, of t to the negative 1. Now, the negative 1 can be a little scary, so let's rewrite this in a different way. As we know, t to the negative 1 can be rewritten as 1 over t to the 1 power. Or as definition says, t to the negative x equals 1 over t to the x. So let's do that here. Don't drop your limit. Limit as t approaches 2 of 1 over t. Now we'll plug in our 2 for t. This yields 1/2, and that is the answer. Now we have limit as y approaches 4 of 1 all over root 6y plus 1. It may look scary off the bat, but remember, all we have to do in this case is plug in our 4 for our y. Let's give that a shot. So we have 1 over root 6 times 4 plus 1. This simplifies to 1 over the root of 6 times 4 is 24 plus 1, and this gives us the root we all know and love, square root of 25. So this becomes 1 over plus or minus 5. And that, our last problem, limit as t approaches 25 of 3 root t minus 1/5 t all over t minus 20 squared. You might be saying, Mr. Math, this problem looks impossible. Well, I can guarantee you it's not impossible. It's actually quite easy. All we need to do, as we've done in previous problems, is plug in our 25 for t. Let's give that a shot. So we have 3 root 25 minus 1 over 5 times 25 all over 25 minus 20 squared equals, this will simplify to 3 root 25, it's just 5, minus 25 over 5 is 5. 25 minus 20 is 5 squared. This simplifies to 15 minus 5 over 25. This simplifies to 15 minus 5 is 10 over 25. Let's divide both of them by 5, and this yields 2 over 5, and that is our answer. I want to thank everyone for watching this fun video about basic limits in our Calc 1 series, and stay tuned for our next video. Thank you very much for watching, and have a great day.